Hi everyone, I'm very glad to do this teaching video. The topic that we are going to introduce is probability. We will illustrate probability by several ways, such as function, definition, and the history about it, and so on. We will also solve some simple questions in this class. Well, now I'm going to start with the function of the probability. It is also can be asked why we need to study probability. Probability is a very important way of assessing, and it is applied to all areas of our life. Let me tell some example. For example, investment, financial management, and production cost rate. If we can use probability well to do these things, we may get more profit. If not, we may face to lose lots of money. I think that is not we expected. In addition, probability also can help people to do the weather forecast and the questionnaire, which are very common in our daily life. This is the reason that's why we need to study probability. Well, let's move to the next page. This is what I want to explain now. The definition of probability. What is the probability? Probability is a measure of the likelihood of an random event occurring, with a number between 0 and 1, representing the probability of one thing happening. When the number is more close 1, the event will be more likely to occur. When the number is more close 0, the event will be more unlikely to occur. I think we can easily understand this by this number axis. We can easily find that the likelihood of an event from 0 to 0.5 to 1. It means the impossible event and something percentage 50 will happen, and certain event. And it also we can see the likelihood is increasing with the number increasing. Okay, this is the definition of the probability.
Okay, then we will learn about the history of probability. The people who first built the probability of the first system is Jerome Cardan. He's an Italian, and this is his Italian name. It's just like an encyclopedia in Italian Renaissance. In the 16th century, Cardan wrote a book about gambling. As we all know, probability is very important in gambling, and after that, the probability became used in the insurance industry. At the end of the 16th century, some countries put probability in other areas, and the 18th century is the period of probability formation and development. There are some masterpieces like opportunity principle and the contingency experiment. The 19th century probability theory was developing towards the establishment of a complete theoretical system and a widened range of application. Means probability became used in more areas. The representative person, Maxwell, Laplace, Gauss, Gibbs. Okay, after the 20th century, the theory of probability developed slowly but expanded the scope of use, significantly reducing the risk of many things. Nowadays, probability became normally used in our daily life. For example, when a company wants to do some investment and the professional staff show the date to tell them the probability of they can get high return, and after see the probability is high or low, the company can make a better decision. And here are three men who contribute a lot in the development of the probability: Cardan, Jacobo, Daniel.
There are several simple probability questions in our history. The first one is the probability of singly. The probability of taking a number in a set of numbers. Let me show you an example. There are 5 same pen except color in a bag. Each pen has different colors: red, orange, yellow, green, and blue. In the case of the North Sea, take the probability of the red pen. And the second one is that many times have written to the type of the singly. From a set of data, take a number in time, get a specific number of probability. For example, Victoria Falls. The third one is that many times we are written type of singly. With many times have written to the type of the singly in different place, is that the number will be taken away and not be put back. For example, there are 12 cheesy pieces in the pot, of which 8 white, 4 black, from which you take 3, the probability of all white cheese pieces. And the final one is that compare the probability of the 2 events. Just compare the probability of the 2 things happening. For example, A happened, and what is the probability of the B will be happened? And now, I will introduce the solution of the third question. This question is the most flexible in this question. Many times we are written type singly, and there are 2 ways to deal with this question. The first way is to use the formula PA equals A divided C. The number A is take the number of the n elements from the number of the n elements in a row. The n should be lower than n or equal n. And the formula is that an equals the factory n divide the factory n multiply the factory of the n minus n. And then another way is use number C. The number C is take the number of the n elements from the number of the n elements in a group, and the n should be lower than n or equal n. The formula is that CNN equals the factory n divide the factory n multiply the factory of the n minus n. To sum up, in the last, this function can be used in any situations.
Now, I will show another way to solve this kinds of question. First, calculate the probability of each type, and multiply each probability. We will use the formula in this way is PAB equal PA multiply PB. The theory about this way. First, calculate the probability of each time. Each time, all like once, probability of single sampling. So this way is just calculate the probability, and this probability of single sampling occur together. Now, I would like to show an example to help you better understand these two models. The example question is there are 12 chess pieces in the pot, of which 8 white and 4 black, from which to take 3. We need to calculate the probability of all white chess pieces. Use the first way to deal with this question. The formula is PA equal A divided B. So we need to calculate the A first. The A equal the factorial of n, divide the answer of the factorial of n, multiply the factorial of n reduce n. In this question, the n equal 8 because we want to get white, and in the pot have 8 white chess pieces. The n equals 3 because we need to get 3 times and get the 3 chess pieces. So A equal the factorial of 8 divide the answer of factorial of 3, multiply the factorial of 8 reduce 3. The answer is 56. And then we need to calculate the C. The C have the same formula with A, but the n answer is not same, because is take the number of m elements from the number of n elements in a group, but A is in a row. So in the C formula, n equal 12 because there are 12 chess pieces in the pot. So C equal the factorial of 12. Divide the answer of factorial of 3, multiply the factorial of 12, reduce 3. The answer is 220. So now we use the formula PA equal A divided B. The answer is 56 divided 220. The answer is 14/55. The second way, I think there's a simple way to deal with this question. Let's pause this question. The first time to get the white pieces, because there are 12 chess pieces in the pot, and we will get the white pieces. There are 8 white pieces in the pot, so the first time we get the white chess pieces probability is 8 divided 12. The second probability, because we need a hypothesis. The first time we really get the white pieces, so in the second pieces we lose the white pieces and we lose the white pieces. So together in the pot we have 11 chess pieces and 7 white pieces. So the probability of get white chess pieces in the second time is 7 divided 11. The third use the same way to deal with this. The probability is 6 divided 10. Now we use the formula to get the answer is P equal PA divided PA multiply PD multiply PC. This is 8 divided 12 multiply 7 divided 11 multiply 6 divided 10. The answer is 14/55.
Better understand.